So, good evening all, welcome to Sakala Vidya YouTube channel. So, in the last class actually we have discussed problems on limits. Today also we will continue the problems. So far our regular subscribers are joining now, and today some new sir tomorrow morning topic. Okay, still not yet completed, that I will decide. Okay, Jyoti, Sanjay Rani and Madhurima joined, Gopasri, Ramakrishna and Guru Raju. Guru Raj is new. Yes, next Samir, okay, Ashwa Reddy, Sandeep Kumar, Kataka Mahesh, Madhurima. Okay, next Sudha, Uchika, Jarif Ahmad, Krishnavamshi, Kulwant, Veeraswamy, Krishnamurthy, Hari Krishna, Balu, Dr. Ravi, Sunita, Ujjwal Singh. So far these are joined. Preeti, Lavanya, next Bilvika, Prabhavati. Prabhavati, you are new, I think so. Abhishek, Khatam, Prasanna, yes, you are regular. You are Abdul Majid, Venkat Charan, Gopasri, Archana, Sai Ritesh, okay, Viru, Surya Prakash, hi, Surya Prakash, Pandu Naik, Lokesh, Chandana, yes, Akhil, okay, Anand, Sandeep, Indira Reddy, next Akila, Surya Prakash, okay, Surya Prakash, Sushma, Sandeep Kumar, okay, Venu. Okay, now let us start the problems today. Srikant. Okay, so any newcomers are there, so you need to subscribe. Okay, so what is the question number? So yesterday question number, anybody? Okay, question number, limits, 24th question. Okay, thank you. So 24th question, right, thank you Deepti, thank you Madhurima, Chandana, right. Limit extends to infinity, okay, sine of root over x plus 1 minus sine root x equals to, this is the question. First option 2, second option minus 2, third option 0, fourth option is 1. So this is the today's first question. Okay, so good evening all, Nagalakshmi, Janapriya, new, you are also new. Okay, limit extends to infinity, sine of root over x plus 1 minus sine of root x. So that means this can be done sin c minus sin d formula. So let us say this is c, this is d, apply sin c minus sin d formula. What is sin c minus sin d formula? Sin c minus sin d equals to 2 cos of c plus d by 2 and sine of c minus d by 2. Am I correct? Okay. So, now this given expression or given limit, we can write limit extends to infinity. This we can write 2 cos of root of x plus 1 plus root x by 2 and next sine of c minus d, root x plus 1 minus root x upon 2. This we will get it. Sir, when will you do a video on Anuradha garu? I think you are the first class to you. Okay, message stop cheyandi please. We cannot visible question. Where? Okay, please, we cannot visible question. Right. So, now take 2 common, limit extends to infinity. We can write this is cos of root of x plus 1 plus root x upon 2. And here one interesting factor you need to remember, we need to rationalize the numerator. So, that can be rationalized here. See, that means separately I will do root of x plus 1 minus root x by 2. So, this can be rationalized like this, root of x plus 1 plus root x by root of x plus 1 plus root x. See, this one we will get it now, a minus b into a plus b, we get a square minus b square, root x plus 1 whole square x plus 1 minus root x square x by 2 times you will be getting root of x plus 1 plus root x. This x gets cancelled, 1 by. So, that means instead of this we can write 1 by 2 times root of x plus 1 plus root x. So, now one interesting factor, as x tends to infinity, root of x plus 1 also tends to infinity, infinity plus infinity, infinity itself only. That means infinity is a very real number. So, whenever that is a real number, for all real values here, this cos value is takes finite value. So, that means actually here cos lies between, for example, say this value is equal to theta. So, minus 1 less than or equal to cos theta less than or equal to 1. That means the value of this cos oscillate between minus 1 and 1 and it attains finite value. So, it attains a finite value. So, that may be finite value only, but whereas here see infinity plus infinity. So, infinity plus infinity is infinity only. So, that means actually here we get 1 by infinity, 1 by infinity means this becomes 0. So, that means 2 multiplied by some finite value multiplied by this will be sin 0, because 1 by infinity is 0. So, that means 2 multiplied by finite value into 0. So, 0 into something you get 0. So, that means third option is the right option. Which book you are following, please tell. So, first Krishnamurti garu, actually you seems to be a, so now the professor I think so, your photo, your DP, right, thank you. Next 25th question. Question. Right. limit extends to infinity, x cos of pi by 8x, and next sine of pi by 8x equals to first option pi, second option right pi by 2, so third option is pi by 8, fourth option is pi by 4. So now here see, limit extends to infinity, x cos of pi by 8x sine of pi by 8x. Okay, let us try ourselves first. See, first this can be written like this problem now. Solution, limit extends to infinity, cos of pi by 8x multiplied by sine of pi by 8x upon this 1 by x write down. If you simplify, again x comes in the numerator. So one thing you do it now here, multiply and divide by 2. So what do you get now here? Limit extends to infinity. This can be, numerator can be rewritten as 2 sine of pi by 8x cos pi by 8x multiplied by upon 2 by x, okay, or 2 into 1 by x. So we have one formula, 2 sin A cos A, so which can be written as sin 2A, okay. This is the formula we have, okay. With the help of this formula, so now we can write this is equal to, this 1 by 2 is taken common out, 1 by 2 limit extends to infinity, this is 2 sin A, this is A, this is B, sorry A only, this is A, 2 sin A cos A is equal to sin 2 times A, that means sine of 2 into, actually you will get like this, 2 into pi by 8x, that will be sin pi by 4x upon 1 by x. So let us say this 1 by x is equal to theta. For example, very interesting factor, as extends to infinity, the theta tends to 1 by infinity means 0. So now this problem we can change as like this, limit theta tends to 0, sine of pi by 4 times theta by theta. I already explained one shortcut to you. See what is the shortcut means, limit theta tends to 0, sine A theta by theta is A. So that is why we will be getting, this will be pi by 4, that means half times, already half is there, into pi by 4, whose value is equal to pi by 8. So third option is the right option. Yes, 1 by x is equal to 0 only we have used here, right. I think the screen may, you will get it shortly. So, 26th question, limit extends to infinity x minus log x by x plus log x. This is the question. Is it sufficient for Eamcet, sir? Screen is not clear. Okay. I think there is a problem. Here is clear only itself only. So, now first option is 1, second option is -1, third option is 0, fourth option is 2. Okay, limit extends to infinity x minus log x by x plus log x. Here see, we have limit extends to infinity. You remember this formula, log x by x equals to 1, or you can apply L'Hospital's rule and you will get it now, this one. You remember this one. So, that means from numerator take x common, from denominator take x common. Then what do we get? Let us see solution. Here x is taken from common from numerator, we get 1 minus log x by x or log x upon x. So, in the similar manner, take x common from the denominator, x into 1 plus log x by x. Even if you open the brackets, you will get same thing itself only. Limit extends to infinity. Here x gets cancelled, we have. So, this equals to 1 minus this is let us do it log x by x. Log x differentiation is 1 by x, this will be 1, 0, you remember this is 0. Okay. So, that means now you can remember 1 minus 0 by 1 plus 0. So, answer is 1. First option is the right option. So, once again I repeat, limit extends to infinity log x by x 0, you remember that one. So, then this problem very easily we can solve it. Okay, and one more thing you remember, limit x approaches to infinity, even 1 by x also 0, even 1 by x square, 1 by x cube, 1 by x power 4 also 0. Twenty-seventh problem. Limit extends to infinity x square plus ax plus a square root of minus root over x square plus a square equals to, first option is 0, second option is a by 2, third option is minus a by 2, fourth option is a. This is the question. By differentiating numerator and denominator, we can get the answer. Yes, you can apply L'Hospital's rule. You can apply L'Hospital's rule, no problem, Venkateshwarlu. You can do it. right. So now limit extends to infinity, the root over x square plus ax plus a square minus root of x square plus a square is equal to. So now it had better to actually now rationalize the numerator. So with the help of root of x square plus ax plus a square plus root of x square plus a square. Okay, after that exactly correct what you said, x square we need to take common, right. Let us do it now. So now the solution follows like this: limit x tends to infinity, x square plus ax plus a square root over minus x square plus a square root over multiplied by x square plus ax plus a square root over plus root of x square plus a square, rationalizing factor, and upon root of x square plus ax plus a square plus root of x square plus a square. Okay. So that means now if you multiply these two, so that will be in the form of a minus b into a plus b. So that can be written a square minus b square form. So that is equal to, we get now x square plus ax plus a square and minus x square and minus a square upon, you will be getting this value. So x square plus ax plus a square root plus root of x square plus a square, now having been limit applied here, that is limit x approaches to infinity. Here x square gets cancelled and a square gets cancelled. So now we have so this equals to limit x approaches to infinity or x tends to infinity ax by, so now in this one take out x square common. If you take x square common, we have 1 plus a by x plus a square by x square root plus, here also take out x square common, we have 1 plus a square by x square under root. Okay. So now the next step we get it now, this equal to ax upon, here square root of x square is x, root of 1 plus ax plus a square by x square, here also square root of x square is x is taken common out, and plus root of 1 plus a square by x square. So limit x tends to infinity. Now x gets cancelled, we have. Now as x tends to infinity, that implies this a by x, a square by x square becomes tends to 0. So this becomes 0, this becomes 0 and this becomes 0. So we have now a by root 1 plus root 1, that is a by 2 is the answer. So second option is the right option. Right. So that means whenever this kind of problem is given, simple technique you can remember, x coefficient by 2. Answer is here, you can remember like this tip. Required limit is equal to coefficient of x by 2. Here coefficient of x is a, so answer is a by 2. That's all. This is easy tip, you can remember. No sir, by taking x common, x square common, infinity into 0 0, no. Okay, please send me morning classes. Ashwini Mariala. Okay, right. What is the question number? What is the question number? What is the question number? Okay, I will check it. 27th. Okay. 28th question. Okay. For a greater than 1, then limit x approaches to infinity, a power x minus a power minus x upon a power x plus a power minus x equals to. So now the first option is 1, second option is 1 by 2, third option is 1 by 3, fourth option is minus 1 by 15. Sir, if you follow your regularly, Garimella Amruta, you are newly joined. Can we score? So if you are regular, I can sure. So just today only you joined. Am I correct or not? Okay. A greater than 1, then limit extends to infinity. A power x minus a power minus x upon a power x plus a power minus x. So now here we have one condition. If a greater than 1, then a greater than 1, as x approaches to infinity, the a power x is also approaches to infinity, but whereas 1 by a power x approaches to 0, that we can confirm. So that means now, so better you do one thing, now divide both numerator and denominator by a power x. So this we can write like this now, limit x approaches to infinity, or you can take out a power x common also, 1 minus a power minus x by a power x upon, in the denominator also take out a power x common, 1 plus a power minus x by a power x. So, this a power x gets cancelled. So, now this can be written limit extends to infinity. This we can write 1 minus a power m, formula we have a power m by a power n is equal to a power m minus n. We can use this formula. This is equal to minus x minus 2x by 1 plus a power minus 2x. So, for our convenience we can write 1 minus 1 by a power x whole square. Can I write like this? That is nothing but 1 by a power 2x upon 1 plus this also we can write 1 by a power x whole square. Here limit we have x tends to infinity. So, now 1 by a power x is 0. So, this becomes 0, this becomes 0. So, we have 1 minus 0 square 0, 1 plus 0 square 0. So, answer is 1. So, that means first option is the right option. Ruchita, you didn't actually attend for the first class. No, by CD rule we cannot apply here, because the CD rule, in order to apply CD rule we need actually here two ratios. When we compare the two ratios we can do it. Very good evening Chandu. Thank you. So, 29th problem. Okay, no problem. Limit x approaches to infinity, 2x plus 7 sin x upon 4x plus 3 cos x equals to. Sir, my net was problem in the morning. Which chapter you tell me in the morning? Vaishnavi, actually in the morning I dealt inverse trigonometric functions. Any shortcut methods are, because time is not sufficient to do problems. So, how many shortcuts you can apply, Anita? You are the first class, I think so. Bhumika Reddy, you are also new. Okay. First option is 1, increase your volume. Second option is minus 1. Third option is 1 by 2. Fourth option is minus 1 by 2. Okay. So, limit x approaches to infinity, 2x plus 7 sin x upon 4x plus 3 cos x. Here we need to discuss actually two concepts. Let me discuss two concepts here. One concept is actually limit extends to infinity, sin x by x is what? And limit x approaches to infinity, what is cos x by x? If we address these two concepts, this problem easily we can solve. So, now let us solve it now. Here see, first limit x approaches to infinity, sin x by x. Let us have a discussion here. So, limit x approaches to infinity, this can be written 1 by x multiplied by sin x. Always sin x and cos x are called oscillating functions. What do we call oscillating functions? Means the sin x and cos x lies between minus 1 comma 1. So that means it is a, actually always remember, a finite value, but whereas this 1 by x is 0, 0 into finite value is, so we get 0. That means limit x approaches to infinity, sin x by x is equal to 0. In the similar manner, limit x approaches to infinity, cos x by x also, you can write like this, limit x approaches to infinity, 1 by x multiplied by cos x, 0 multiplied by finite value 0. Now let us come to the problem now. Here solution, let us start the here. Take x common out from the numerator, take common out from x common out from the denominator. So we get like this, x is taken out, 2 plus 7 times sin x by x. So in the similar manner, if you take x common from the denominator, we get 4 plus 3 cos x by x. So now limit is applied, limit x approaches to infinity, x cancel. Now tell me what is our answer. So sin x by x is 0, cos x by x is 0. So now it is replaced by 0 and it is replaced by 0. So we get now 2 plus 7 into 0, 0, 4 plus 3 into 0, 0. 2 by 4 is 1 by 2. So third option is the right option. Now the question number 30. Question number 30. Thank you Chandana. Sanjharani, right. Limit x approaches to infinity, 8 mod x plus 3x, 3 mod x minus 2x. First option is 11, second option is 8, third option is 0, fourth option is 1 by 8. This is the question. Dhruv, Ansh, actually today you joined. Am I correct? Yes? Right. So limit x approaches to infinity, 8 mod x plus 3x by 3 mod x minus 2x. So first let's have a discussion on the mod x function. See, the mod x is equal to x when x greater than or equal to 0, equal to minus x when x less than 0. Am I correct now? So x approaches to positive infinity, that means x is greater than 0. Therefore now the mod x is defined as x. Now the problem becomes like this: limit x approaches to infinity, Now this mod x is equal to, we can write x, this mod x is equal to, we can write x. So 8x plus 3x upon 3x minus 2x. So let it be simplified now. So this equals to 11x by x, limit x approaches to infinity. X gets cancelled. If limit applied to the constant function, you get constant only. So 11 is the right answer. Thank you, thank you, thank you, Madhurima, Chandana, Sudha, Gopasri, right, Jyoti. Oh, everybody. Okay. Sandeep. Okay. Now the 31st question. Limit extends to infinity, x plus 1 all to the power of 10 plus x plus 2 all to the power of 10 plus so on dash dash x plus 100, even x plus 20 also you may write it, no problem, all to the power of 10 upon x to the power of 10 plus 10 to the power of 10 equals to, okay, Pavan, right, Arjun, okay. First option is 10, second option is 100, third option is 1000, fourth option is the previous videos are available. Okay, that you can watch, Arichandana, right. Fourth option is 1, right. Limit x approaches to infinity, x plus 1 all to the power of 10 plus x plus 2 all to the power of 10 plus and so on plus x to the power of 100 all to the power of 10 upon x to the power of 10 plus 10 to the power of 10. Okay, first actually from the first term, from the first expansion take x common, from the second expansion you need to take x common, that means even the last also you need to take x common. So first let us write like this now, x common, we have x plus 1 by x, in the first term we can write like this, all to the power of 10, am I correct, plus in the second term also take x common here in the bracket, 1 plus 2 by x all to the power of 10 and plus so on dash dash. In the similar manner in the bracket you take out x common, 1 plus 100 upon x and all to the power of 10, am I correct, upon here in the numerator take x to the power of 10 common, we have 1 plus 10 to the power of 10 by x to the power of 10. So that means this is limit x approaches to infinity. So interesting factor is actually here x power 10, here also x power 10, last x power 10, you can take out x power 10 common from all the terms. If you take x power 10 common, you have like this So this is 1, sorry. So 1 plus 1 by x whole to the power of 10 plus 1 plus 2 by x whole to the power of 10 and so on dash dash plus 1 plus 100 by x whole to the power of 10. You need not expand any term, that's all. So upon here x to the power of 10 into 1 plus 10 to the power of 10 by or 10 by x whole to the power of 10. Okay. Limit x approaches to infinity. The x to the power of 10, x to the power of 10 gets cancelled. Here see, when x approaches to infinity, this 1 by x becomes 0, 2 by x becomes 0, 100 by x becomes 0, this 10 by x becomes 0. So we have actually 1 plus 0, 1 plus 1 plus so on dash dash 100 times, because 100 terms are there, by 1 plus 0. So 1 is multiplied by 100 times means 100 divided by 1 equal to 100. Actually 1 is multiplied for 100 times means 100, but in the denominator we have 1, 100 by 1 is equal to 100. So here option is second option. See why the binomial theorem is not defined for the negative values. Who said that the binomial theorem is not defined for negative values? Even rational index also the binomial theorem can be applicable, but one condition need to be applied. Ruchita, remember, see, the mod x should be less than 1, then even we can define 1 plus x whole to the power of minus 1 and 1 minus x whole to the power of minus 1. I think you got it. This latter I will explain regarding this one. Definitely I could remember in binomial theorem, at that time I will repeat your name also. Thank you, thank you. It is defined. Okay. Okay, once again, last I will explain once again, Hare Krishna, don't worry. So 32nd problem. So 32nd problem. Limit. So date has been extended in Telangana up to May 5th. Have you applied, Arjun, first of all? Have you applied? First you apply, then date will be announced later. What Mr. Sandeep said, exactly correct. I will coincide with Sandeep Kumar's statement. Okay. Limit n tends to infinity three into 2 to the power of n plus 1 minus 4 into 5 to the power of n plus 1 upon 5 into 2 to the power of n plus 7 into 5 to the power of n equals to first option minus 20 by 7, second option 20 by 7, third option is 10 by 7, fourth option is minus 10 by 7. Sir, first year results when, sir? Bhuvan Chandra, you are also new. Only the new years are asking these kind of questions. Okay, don't worry about the results. Okay, Arjun, good suggestion. Good suggestion. When will it year results will come? Okay, Ambika minus 20 by 7. Okay. So now limit n tends to infinity 3 into 2 power n plus 1 minus 4 into 5 power n plus 1 upon 5 into 2 power n plus 7 into 5 power n. So here so we need to remember actually the first this 3 into 2 power n plus 1 can be written 2 power n into 2 minus 4 into 5 power n into 5 first. So we shall write in the numerator like this. So in the denominator as it is 5 into 2 power n plus 7 into 5 power n. So for example, if you observe 2 power n and 5 power n, this 5 power n will be generally greater than 2 power n. 2 power n. So take 5 power n common out from both numerator and denominator. N tends to infinity. So if you take 5 power n common, we have this is 3 into 2 6 multiplied by 2 power n by 5 power n minus 4 into 5 is 20. 5 power n is already, it has been taken common out. So in the similar pattern, take out 5 power n common, we have 5 into 2 power n by 5 power n plus 7. Here limit n tends to infinity. So now this we can write now, the 5 power n gets cancelled. This we can write 6 into 2 by 5 all to the power of n minus 20 upon 5 times 2 by 5 all to the power of n plus 7. So limit n tends to infinity. So I will explain one condition to you, one important condition. For example, if a less than 1, then limit n tends to infinity, a to the power of n is equal to 0. This is very important fact, need to be remembered now. So here 2 by 5, for example 2 by 5 is a, 2 by 5 is a proper fraction, that is less than 1. So as n approaches to infinity, if you apply a power n is equal to 0, this becomes 0, this becomes 0. We have 0 minus 20 by 0 plus 7, whose value is minus 20 by 7. So that means first option is the right option. Ramanathan, you are also new. Sivasankar, no problem, no problem. Okay. 33 problem. Okay, 33 problem. Limit n tends to infinity 1 by n cube into 1 plus 3 plus 6 plus and so on plus n into n plus 1 by 2. First option is 0, second option is 2, third option is 1 by 6, fourth option is 1 by 3. This is the question. Okay, 1 minute. So, this is the question. Limit n tends to infinity 1 by n cube 1 plus 3 plus 6 plus and so on n into n plus 1 by 2. So, that means here sum of the n terms, that means nth term is given. So, sum of the nth terms is given, that means for example, if nth term or for example 1 minute, suppose nth term is Tn equals to n into n plus 1 by 2. This we can write like this, half common n square plus n. Now, for example, let us say this is sum to n terms Sn. So, now the Sn is given by, you can apply sigma Tn, that means half common we can write sigma n square plus sigma n, we can write it. So, now let us come to the problem now. The solution, the problem solution, this is the plan before going to the solve problem now here. So, now limit n tends to infinity, we can write here half common out sigma n square by n cube plus sigma n by n square, n cube, sorry, this you will get it. So, now I explain one shortcut to you, one important shortcut. Limit n tends to infinity, this is a shortcut you need to remember everybody, sigma n to the power of k by n to the power of k plus 1 is there, 1 by k plus 1. This is one shortcut. Second shortcut you remember, limit n tends to infinity, this is n to the power of k. For example, this will be n to the power of something less than k, k minus 1, k minus 2, whatever it may be, k minus 1, it will be 0. So that means this becomes actually 1 by 3, already half is there, plus this becomes 0, this becomes 0. So answer is 1 by 6. So third option is the right option. So this binomial, no, I didn't apply any binomial. Sivasankar, you are the new, you are new. Anybody give the schedule to them? Yes, not binomial. Right. Thirty-fourth question. Limit extends to 1, 2 minus x whole to the power of tan of pi x by 2 equals to. This is the question. Ramanaya Gogula, you are new to the class. Yes. First option, e to the power of 1 by pi. Second option, e to the power of 2 by pi. Third option, e to the power of minus 2 by pi. Fourth option is e. This is the question. Okay. Yes, Dhruv Anshu, can apply log on both sides. Yes, you can apply. If you want to leave the session, leave. Don't chat unnecessarily and don't discourage others. Okay, thank you, Sandeep. Thank you. Limit extends to 1, 2 minus x whole to the power of tan of pi by 2 x. For example, if you substitute the limit, you will be getting 2 minus 1 whole to the power of tan of pi by 2. This appears to be 1 to the power of infinity form. This is the one of the indeterminate forms, 1 to the power of infinity form. So whenever 1 to the power of infinity form, okay. So please concentrate, all of you. Please concentrate. Today I will continue up to 9:30. Okay. So now, so we have one formula. Let me discuss. Limit extends to infinity, f of x to the power of g of x, which is in the form of 1 to the power of infinity form. Then this we can write e to the power of g of x into f of x minus 1, limit x approaches to infinity. You remember this shortcut. So now this is equal to, we can write e to the power of limit x approaches to 1, anything you can write, limit x approaches to a also we can write, no problem. Limit x approaches to 1, here g of x is tan of pi x by 2 into f of x. This is f of x. This is f of x. This is f of x. 2 minus x minus 1. So, this equals to e to the power of limit x tends to 1. This will be 1 minus x by the tan pi x by 2, you can write cot of pi x by 2. Now, if you put the limit, you will be getting 0 by 0 form. You can apply L'Hospital's rule. So, that means differentiation of 1 minus x is minus 1 upon cot differentiation is minus cosecant square of pi x by 2 into pi x by 2 differentiation is pi by 2. Here e to the power of limit x tends to 1. This minus minus gets cancelled. So, we have this will be 2 by pi. If x is equal to 1, cosecant square pi by 2 is cosecant 91. This will be 1. So, you get e to the power of 2 by pi. So, here second option is the right option. Hare Krishna, if you want, you can leave. Right. 35th question. Limit x approaches to infinity, a power 1 by x plus b power 1 by x plus c power 1 by x upon 3 whole to the power of x equals to. This question is very important. Okay, yesterday you all of you requested me to continue up to 9:30 p.m. So that's why keeping you of your requisition. So today I would like to continue. Shall I continue or shall I stop? Depends upon yourself only. Okay. So first option is 0. Second option is cube root of ABC. Third option is 1 by cube root of ABC. Fourth option is 1. This is very important question. This is very important. I will discuss in between some important problems also here. Please note down, all of you note down. See, limit x approaches to 0, a power x plus b power x by 2 whole to the power of 1 by x is root ab. Limit x approaches to 0, a power x plus b power x plus c power x by 3 whole to the power of 1 by x. Now you can expect the answer, cube the root of ABC. Okay, please note down. Limit x approaches to 0, a power x plus b power x plus c power x plus d power x upon 4 whole to the power of 1 by x. Tell me what is the answer. fourth root of a into b into c into d. Okay. Now limit extends to 0. Now 1 power x plus 2 power x plus 3 power x and plus so on dash dash n power x upon n all to the power of 1 by x. Tell me what is the answer? What is the answer? What is the answer? Net problem. What is the answer? Your answer is 1 into 2 into 3 into 4 into so on dash dash into n and nth root. Am I correct now? So this is nothing but product of the first n natural numbers, nothing but n factorial. So that means nth root of n factorial, or we can write nth root of factorial n. Okay. Yes, root over, that's correct, nth root of. So this better you note down 1, 2, 3, this is 4 problems. In between in this I have discussed the 4 problems now. So let us come to the now our problem now. What is the problem now? Here limit x approaches to infinity, a to the power of 1 by x plus b to the power of 1 by x plus c to the power of 1 by x upon 3 all to the power of x. Here let us say this 1 by x equal to some capital X. See, as x approaches to infinity, this capital X approaches to 0. Now we can change the problem. See, this problem we can write as like this: limit capital X tends to 0. This will be a power capital X plus b power capital X plus c power capital X upon 3. This small x is equal to, we can write 1 by capital X. Already we have discussed. This is cubed root of ABC. That's all answer. So here option is second option. Understood now? It's very important problem we have discussed here. Yes, even you can apply that also. Okay. Yes, in the one problem only we have discussed 4 problems. So 36th problem. Net problem is for your side, for our side. Limit n tends to infinity, 1 plus sin a by n whole to the power of n. First option E. Okay. Sir, can you please prepare day by day lesson schedule? Okay. Second is e to the power of a. Third is a to the power of e. Fourth is a. See, this problem very easy manner we can do it. Okay. So now as n approaches to infinity, this a by n tends to 0. As sin of a by n tends to 0, sin of a by n approximately equal to, you can write a n. Now the problem becomes, solution becomes like this. Limit n tends to infinity, 1 plus a by n whole to the power of n. So we have one formula. Limit n tends to infinity, sorry, x tends to infinity, 1 plus a by x whole to the power of x is equal to e power a. This e power a we can write. Same, this is equal to e power a. Second option is the right option. Kanakala Sai, just you type 2, that's enough. Thirty-seventh question. If f of 9 is equal to 9, f dash 9 is equal to 4, limit x tends to 9, root of f of x minus 3 by root x minus 3 equals to, this is the question. Dhanush, actually you are new to my class, please actually watch my previous video. So that means actually in physics you might have applied, when x is very small, the sin x is approximately equal to x. In the similar manner, a by n is very small, sin of a by n equals to a by n. That's only I have written. First option 4. Yes, we can neglect it. We can neglect. That's correct, absolutely. 1 by 4. Third is 1 by 2. Fourth is minus 1 by 4. This is the question. Thank you, Dhruv. It means it is negligible. That is actually in general we call errors and approximates also, we shall discuss the same concept. F of 9 is equal to 9, f dash 9 is equal to 4, limit x tends to 9, root f of x minus 3 by root x minus 3 we need to find. Okay, now the solution. So limit x approaches to 9, root f of x minus 3, root x minus 3. First substitute the limit, root f9 minus 3 upon root 9 minus 3. F of 9 is equal to 9, root 9 is 3, 3 minus 3 by 3 minus 3, 0 by 0 form. 0 by 0 form is indeterminate form. We can apply L'Hospital's rule. LH rule. LH rule. That means numerator and denominator are to be separately differentiated. So derivative of root f of x is 1 by 2 root f of x into derivative of f of x is f dash x, that should be written minus 3 differentiation 0. In the similar manner, root x differentiation is 1 by 2 root x and minus 0, this equals to limit x approaches to 9. Now this can be written, so limit is applied here we have. So this we can write f dash x by 2 root f of x into 2 root x by 1. Now the limit extends to 9. Let us apply the limit. F dash 9 by 2 root of f of 9 into 2 root 9 by 1. Okay. So now we get this is equal to f dash 9 is equal to 4. 4 by f of 9 is equal to 9. Root 9 is 3 into 6, 4 by 6 into here we have 2 into 3, 6, 6, 6 cancel 4. First option is the right option. So 38th problem, f of a equals to 2, f dash a equals to 1, g of a equals to minus 1, g dash a equals to 2, then limit extends to a, g of x into f of a minus g of a into f of x upon x minus a equals to first option First option 1 by 5, second option is 5, third option is minus 1 by 5, fourth option minus 5. Okay, now f of a equals to 2, f dash a equals to 1, g of a equals to minus 1, g dash a equals to 2. So that means if you substitute the values here, definitely you will get 0 by 0 form. So that means you need to apply LH rule. LH rule means g dash x into f of a constant minus g of a into f dash x upon x minus a differentiation is 1. Now limit x approaches to a, this equal to g dash a into f of a minus g of a into f dash a. So this equals to g dash a equal to 2 into f of a equals to 2 minus g of a equals to minus 1 into f dash a is equal to 1. So this is 4 minus into minus plus 1 into 1 plus 1 equals to 5. So this is the answer. Okay, now tomorrow we shall continue. Okay. Thank you. Every day at least 10 or 20 minutes I will extend in the class. Thank you, one and all. Bye bye. All of you subscribed? Okay, good night. Okay.